Hello friends, welcome to this channel. In this channel, I will be solving the questions related to various subjects in electrical engineering GATE exam, and these will be helpful for students in other exams also. And today I am going to discuss a question which is related to control system, and subsequently in other videos I will be discussing the questions related to other subjects also. The questions will range from easy questions to hard questions, and these can be very helpful for you during your preparation, and it may also be helpful in other exams. So let's get started. So this is the first question that we will be doing today, and let me read the question for you. The root locus diagram of a unity negative feedback control system with loop transfer function SGS is equal to K over S plus 2 is intersecting zeta at 0.5, zeta equal to 0.5, which is shown in the figure. So you can see here this is intersecting at a point, zeta is equal to 0.5. So this is 60 degrees because this angle, this line is like it's cos inverse zeta. Okay, cos inverse zeta. So it is 60 degrees. Okay, or pi by 3. So he is asking that what should be the value of k for which this this is true, means zeta is at 0.5. So uh, it's a fairly easy question. You can try it first before seeing the solution. So let's try it. So you know that any control loop, a control system is given as GS. Say this will involve a plant and a controller, everything, and it will have an HS. Okay, this is the feedback part, and this is the input RS and output say YS. So here loop transfer function means product of GS and HS. Okay, so we are given the product of GS and HS. So if it is a unity feedback system, so HS is equal to 1. So we are given GS is equal to K over S plus 2. This is a typical second order system. Okay, so for deriving the answer to this question, what we can do is we can compare it with the typical second order system control loop, which is given a loop transfer function, which is given by omega square over S into S plus 2 zeta omega n. Okay, so what we can say is, again I will write it, we can compare it with omega n squared over S plus 2 zeta omega n. Okay, so you can say that this, if I want to draw the root locus for this, so it will be one pole at origin and one pole somewhere here, and they will be diverting like this, and again it will go like this. So he wants us to find this point at what gain we are intersecting such that this is 60 degrees. Okay, so how to proceed? What we can do is, here in this case, you can go like this, because we need the value of k for which that happens. So already we know that it is k over s plus 2. So if you know this one, you know that omega n squared plus s square plus 2 zeta omega ns equal to 0. This will be the equation. Okay, and this will be the denominator of the entire control system. And we know that the poles for this, if it is complex, because he is asking at zeta is equal to 0.5 line, so already it means that the poles are complex. Then we know that if we find the roots of this, it will be given as zeta omega n plus minus omega n under root 1 minus zeta squared. So these will be the poles. So this this these are the poles. Okay, so this same thing we can do, and we can compare now these two equations, and we see here that 2 zeta omega n is equal to okay, first let's form again the equation, the denominator equation. So it will be s square plus 2s plus k is equal to 0. Now I will compare this with s square plus 2 zeta omega ns plus omega n squared is equal to 0. So you can get from here that omega n is equal to root k, okay, and 2 zeta omega n is equal to 2, okay. So so it means, okay, again I will write it here. It means omega n is equal to root k, 2 zeta omega n is equal to 2, okay. So if you cancel this thing, you get zeta omega n is equal to 1, okay. Now from here you know that omega n is equal to 1 by zeta, okay. So this can be substituted in this equation, okay. So we see that 1 by zeta is equal to under root of k. So uh, if we square both sides, we get 1 by zeta squared is equal to k, okay. Now zeta is already given as 0.5, so k is equal to 1 over 0.5 squared, which is equal to 1 by 0.25 is equal to 4. So this is the answer to the question. So what you really need to remember here is, whenever you get a question like this, you need to compare it with second order system. Second order system is given as omega n squared over s into s plus 2 zeta omega n, okay. And the transfer function denominator, or the characteristic equation, you can say, it is given as this. You can use this, and from here you will get s square plus 2 zeta omega ns plus omega n squared is equal to 0, and you can compare this with the equation already present or given in the question, and from there you can get the answer. So the answer to this question is k equal to 4. So this was a very easy question. So like that you can proceed, and you can do a question which is related to a second order system. So in the next video I will again be taking another question related to control system, and I'll be solving it. So for now, thank you for watching.